All right, we've made it as far as page 3 of the notes set for solving absolute value equations and inequalities. And this is notes 1.5 for Algebra 2. Now, one of the things we've learned so far is that you have to isolate the absolute value to start this problem. So I need to get this part alone, and I'll start by getting the 3 out of the way. Now that I've done that, you can see that I have a greater than sign here. Yeah, the little device that I had you learn last time is that greater sounds like it has or in it, greater. You make a split here, and you essentially make 2 copies of what you just had. So that splits the problem. And solve both sides. But before you do that, you have to alter this one here, and to get the alternate answer, you put the opposite number inside the absolute value by multiplying by -1. And you know, absolute values don't care whether you put the number in or its opposite. So that's why we get 2 answers on many of these. Okay, so here comes the -2 over the other side, and you get, greater than 6. Adding 2 to both sides. Here I'll distribute. Subtract 2 from both sides. Divide by -1. Don't forget to change the direction of the inequality. And I now know that the answers are numbers that are either bigger than 6 or smaller than -2. Now, these absolute value inequalities, there's no equation here, it's not an equal sign. When they have a greater than or less than sign, here it's a greater than sign, then there's a little bit of a trade-off. You have to graph these, the solution set, and that's no fun. But they don't give extraneous answers, so you don't have to check them that way. All right, so let's see. I want to get 6 in and -2. Put a scale. So we want open circles at -2 and 6. And we have to be to the right or greater than 6. And to the left of -2. And that's your graph. The numbers that are shaded all work in the original. No worrying about extraneous on these, but you have the added chore of graphing it. Okay, so on this next one here, we're going to take the 3 over the other side. And subtracting 3 from -39 gives 42. Then to get rid of this multiplication, you have to divide. You can't distribute. Oh, I have to turn the sign around. Okay, I divided by negative. That's why the sign had to turn around. Now, it's a greater than sign, so greater, you're going to use an or. There will be times later in these notes where you use and. Okay, you make 2 copies of the line above. Now, if I left it like this, I would get the same answer both times. The alternate answer you get by multiplying the left-hand side here by -1. Okay, add 3 to both sides on the first one here. Divide by 2 on both sides. Okay, we got one set of answers, everything bigger than or equal to 5. Let me distribute here. Subtract 3 on both sides. Divide by -2, which turns the inequality the other way. And so now I know I've got the numbers that are bigger than or equal to 5, or On the other end, the ones that are less than or equal to -2. So let me get a graph going here. All right, I'm going to put 0 a little to the left here. Whew, I got a scale going. I needed that. All right, I want to be to the right of 5 or to the left of -2. And you'll notice that I used closed dots on those because of the or equal to possibility. Okay, we're going to run across a problem here that is always true. So first of all, subtract 4 from both sides. Divide by -3. And we get this x minus 2 is greater than or equal to -9. Now, at this point, it really takes paying attention here. This is a positive value. And to say that positive numbers are bigger than negative numbers, that's always true. And when it's always true, all real numbers work. So the solution is all real numbers. Everything works. And then you take a number line, a simple number line, maybe put a 0 in the middle there, and you shade the whole thing. Okay, let's summarize these. Oh, no, we got another type, excuse me. We got the less than coming at you. Okay, so with absolute values and less than, you're going to use in-between notation when you're done. All right, so I need you to scribble this out here. This is the old way I did it. And we're going to go absolute value of A is less than N. You do an AND split. And here's some more payoff. You make 2 copies of the original, leaving the bars off this time. And you multiply this by -1 over here. And then you solve both sides. Well, that's not any different than we've been doing, except that we have AND. Now, when you're done, you're going to combine the results. You're going to write it as one statement that's an in-between statement, and I'll have to illustrate that for you. Okay, the absolute value of x is less than 4. Oh, and the little device that will help you remember that is when you get down to this point, if you have a less than sign, it sounds like less than. So there was greater and less than. All right, let's try this here. I'm going to make 2 separate statements. X is less than 4 and x is less than 4, but I need to multiply this by -1 here. Now, when you divide both sides by -1 in this problem, you end up with x over here, and the sign flips, and you get -4. And the numbers that are greater than 4, less than 4, and greater than -4 are between them. So let me draw the graph first. Let's put 0 in the middle here and -5 on the other dots. There's your scale. So we need numbers that are to the left of 4. And they also have to be to the right of -4. Well, that puts you smack in between those two. And so we're going to write this in the in-between notation that I mentioned in class the other day. So here you go. X. You put less than signs on either side, and you put your smaller number at the left and your bigger number at the right. Oops. And there it is. X has to be in between -4 and +4. Okay, I'll pick up on the other side, the last page of this note set.